Bismillahirrahmanirrahim. Welcome to Cambridge Maths. Today we are going to solve a question from mechanics, and the question number 7 belongs to paper 9709/41 for the session May June 24. Let's read question number 7. A particle P of mass zero point 0.2 kg is projected vertically upwards from horizontal ground with speed of 25 meter per second. A says show that the speed of P when it reaches 20 meter above the ground is 15 meter per second. So let's start the solution. As the particle was projected vertically upwards, so simply we can apply the formula of v square is equal to square root over v is equal to square root over u square plus 2as, because we are given the total distance. Look at this, total displacement is 15 meter per second. Initial velocity is also given, so simply we can apply the formula of v is equal to v of p. The velocity, final velocity of particle P is equal to, as I have told, the formula is square root over u square plus 2as. Well, so our initial velocity has also been given, it is 25 square plus, now look at this, the particle was projected vertically upward, whereas acceleration due to gravity is acting downward, so the direction is actually opposite to each other, that's why it will be subtraction. Well, then our acceleration due to gravity is 10 and displacement has already been disclosed to, which was 20 meter above the ground, so 20. Hence our final velocity of particle P is going to be, look, 25 square means 625. 625 minus 400 means 225. Square root of 225 is 15 meter per second. And they have told us that the velocity of P should be 15 meter per second when it was at the height of 20 meter. And we have shown so. So let it be written that we have shown. Let's move on to the immediate next question. The immediate next question says when P reaches 20 meter above the ground, it collides with the second particle Q of mass 0.1 kg, which is moving downwards at 20 meter per second. P is brought to instantaneous rest in the collision. B says find the velocity of Q immediately after the collision. All of us are well known to the concept that when there is a question of collision of two moving particles, that means two particles are moving simultaneously and collide each other, then we simply apply the concept of the conservation of the momentum. So let's start writing the conservation of momentum. Conservation of momentum formula is mp into up plus mq, the second particle is q, mq into initial velocity of q is equal to mp into final velocity of p plus mq into final velocity of q. Let's see what are the information we have. So mass of the particle P is actually, it may be collected from the previous one. Mass of the particle P was what, 0.2, whereas mass of the particle Q is 0.1. So let's write 0.2 and initial velocity before the collision of particle P was already we have obtained. Before the collision, the velocity of particle P was 15 meter per second. So let's write 15 over here, 0.2 into 15, 0.2 into 15. Then look at this, the direction matters here. Whenever we apply the concept of the conservation of momentum, we cannot ignore the direction. Look, already we have come to know that P was moving upward. P was moving upward. This is for P, direction of P, whereas Q was moving downward. Q was moving downward. Okay, so after that they collided at this point. This is Q. Let me show this uh, more precisely. Look, P was moving upward like this. Suppose this is the movement of P. Here is P, okay? Then Q was moving downward, and at this point they collided each other, okay? This was Q. As the direction, look at this direction from this reference point is different from each other, that means opposite direction. So direction cannot be ignored in the application of the concept of the conservation of momentum. As Q's direction was not same or parallel, it is different. That's why we will use different symbol, the symbol of minus. So mass of particle Q is zero point 0.1, and Q was before colliding, the velocity of Q was 20 meter per second. So we will write here 20 equal to mass of P. Mass of P we have already written 0.2, and after collision it is written that P is brought to instantaneous rest, means there was no movement. That's why it's 0. Now velocity, mass of particle Q is 0.1 and velocity of Q is to be obtained. So we will leave it unchanged. Or if we multiply this, it is going to be 3 minus 2 is actually 1 is equal to, it is 0 and 0.1 VQ. Then velocity of VQ is going to be 0.1. Velocity of Q after collision is going to be 0.1 over, sorry, 1 over 0.1. 1 will be divided by 0.1. 1 divided by 0.1. Hence, our velocity of Q after collision is going to be, if we divide 1 by 0.1, it is nothing but 10 meter per second. Now the direction, as our value is positive, so the direction is upwards. We can write that upward because this information may be essential for us for the solution to the next question. So the velocity of Q was, direction of Q was upward after the collision. After the collision, direction of the movement of velocity, direction of the movement of Q was upwards. So this is what the solution to the question number B. Let's move on to question number C. Question number C is on the next page. So let's move on to page number 5. Well, it says when P reaches the ground, it rebounds back directly upwards with half of the speed that it had immediately before hitting the ground. Find the height above the ground at which P and Q next collides. So first collision has gone away. Now we are trying to find out the height when they collided for the next time. So first of all, we should know that what was the speed of P when it reaches the ground, because it was written here that half of the speed was taken by particle P when it was rebounding back. So let's see the speed of P when it reaches the ground. So velocity of P velocity of P when it reaches the ground. And we know the simple formula we can apply for finding the final velocity is nothing but the v square is equal to v equal to square root over u square plus 2as. Well, or initial velocity of P after the collision, we should not forget that, look at this, in the previous question, what was it? In the previous question, it was after the collision, P was brought Look at this. P was brought to instantaneous rest. That means the velocity of P was, initial velocity of P was 0. So we will just substitute here 0. If we substitute 0, it is going to be 0 plus 2 into acceleration due to gravity was 10 and they collided. First collision was above 20 meter. We have not forgotten. Let me show you. Look at this. They collided just after 20, above 20 meter. Look at this. When P reaches the 20 meter above the ground, then they collided. So the displacement was 20 meter. It is going to be 20. Okay. 20. Now you may raise one more question, that why did we use this positive symbol here? Actually, the direction of the movement of particle P was, it was moving downward. We have written here when P reaches the ground. So direction of the particle P was downward. At the same time, acceleration due to gravity was acting downward. So direction was same. That's why there is no necessity of negative symbol. So please don't get confused. So it is, now what is it going to be? It is going to be 400. Square root of 400 means 20 meter per second. Now let's go back to our question. This is the velocity of particle P when it reaches the ground. Then they have told when it rebounds back, when it rebounds back directly upwards with half of the speed. Look at this here. The word is half of the speed. That means when it reaches the ground, it had 20 meter per second. Then when it rebounds, we will write when the velocity of P when it rebounds back rebounds back is rebounds back is UP. Now this is initial velocity when it bounced back. UP is equal to what? UP is, it was half of this velocity, so it is 10 meter per second. Well, so this is the velocity of P when it rebounds back. Well, so we have just found the velocity of P when it was rebounding up. Now the question is actually what is the concept we are going to apply here? Look, when two particles collide each other, they must collide at the same time instant. That means at the same moment as well as at the same height from the ground, because both of them were colliding above the ground. So the height from the ground must be same. That means distance traveled by both of them will be, each of them will be equal, as well as they must collide each other at the same value of t. So this is the crucial information for solving this question, that the moment will be same. That means the value of t will be same, as well as the displacement from the ground, that means height from the ground, will be same. So one after the other we will have to find the uh, required information. So let's see. First of all, we will find the time taken by P. So let's see time taken by P. Time taken by P, because time T and, remember, T and displacement means time and displacement. These are the two information we required. That's why we will little by little find the time taken by each of them. Time taken by P when it reaches the ground. Let's see how much time was taken by t. And we know that for finding time we can apply the simple Schubert formula. So sp is equal to s equal to ut plus half at squared. Okay, so s was, look at this, s was nothing but 20 meters. How to get this 20? Let me show you from the previous question. Look at this, when they collided each other, when they collided each other, they are, look at this, at the height of 20 meter. Look, at the height of, when p reaches 20 meter, then they collided. That means from 20 meter p was coming down, p was coming downwards from the height of 20 meters. So one thing is sure, that the displacement traveled by p to reach the ground was 20. So we can use this 20 over here. If we write 20 over here, then ut, initial velocity, we have already decided that initial velocity after the collision, the p was brought to instantaneous rest. Let me show you again. Look, when the collision, first collision occurred, then p was brought to instantaneous rest. That means initial velocity of p while coming downward for the first time, it was 0, because it started from instantaneous rest. So initial velocity while p was coming towards the ground was nothing but 0. So it is 0 plus half. Okay, will it be plus or minus? Look at this, p was moving downward. Okay, p was moving downward, and acceleration due to gravity is also acting downward, so definitely it is going to be positive. That means direction was same. So half, and acceleration due to gravity is 10 and t square. Well, hence our t square is going to be it is t square, and if 2 goes there, t square is actually how much? 20 over 5, because if we dissolve this, it is going to be 5. Okay, hence our t is going to be actually 5 4 are 20 means 2. So it was actually 2 seconds. That means p took 2 seconds to reach the ground. This is the second step. We should not deviate from our fundamental concept, that we are trying to find the time when they collided, and the displacement, I mean height from the ground, because they collided each other at the same height from the ground as well as at the same moment. So little by little we are finding the time. So first time taken by p when it reaches the ground, for p took 2 seconds to reach the ground. Well, now we will find the distance traveled by p after rebounding back. Okay, so let it be written. Do I have the space to write just below this? Yes, I have space to write this. So we will write distance traveled by distance traveled by p when it rebounds. Well, the same concept we are going to apply, that is SP Schubert formula is equal to UT plus half AT square. Well, so what was the velocity of U? Already we have found that when it rebounds, velocity of P when it rebounds was 10 meter per second. So we will just apply this. It is 10t equal to 10t plus, now look at this, it is no more a positive symbol because p was rebounding back upwards. We should not forget that p was moving upward again, but acceleration due to gravity always acts downward, so direction is different, that's why it is going to be negative. Half, and acceleration due to gravity, that means value of a is 10 and then t square. Okay, so ultimately sp is equal to 10t minus 5t square. This is the displacement or height traveled by P. Now we will find the distance traveled by Q. Okay, let me write just over here. Distance traveled by distance. Now distance traveled by Q. Distance traveled by Q after 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 first collision. After first collision. After first collision. Because all the information we are applying here is after collision. Okay, so after collision, let us see the same concept we are going to apply, that is displacement SQ is equal to ut plus half at squared. Okay, now SQ, okay, look at this. SQ is equal to initial velocity of u. Let us go back to the solution number B. Look at this. Here we have obtained initial velocity of Q after the collision. Look at this. After the collision, it was 10 meter per second. So we are going to apply just this information. Let this be written. It was 10. So if we write 10 here, 10t. Now there is a question, will it be t? Not at all. It is going to be actually not t, it is t plus 2. Yes. Now you may get confused with this information. Why should it be t? If we consider the scenario, look, after the first collision, P was moving downward and then P rebounds back. That means from the ground, when P starts rebounding back, we got the time T. The second T, look at this, T was what? T was the when velocity of P when it rebounds, distance traveled by. Look at this. Here we have written distance traveled by P when it rebounds. That means after the rebounding, we are calculating the displacement. But what was Q? Q was actually moving upward after the first collision. Q didn't stop at all. We have already seen from the solution number B that initial velocity after the collision velocity of Q was 10 meter per second. That means it was never at instantaneous rest. It was continuously moving on. So the time taken by Q was 2 meters more. Already P took 2 meters. Look at this. P took 2 seconds. P took, look at this. Here we have written P took how much? 2 seconds to reach the ground. But this 2 second is going away. After this 2 second, we are calculating the time instant for P. But what about Q? In these 2 second also Q was moving upward. That means the time taken by Q must be more than 2 seconds, 2 seconds more than the time of P, because P is being counted after the rebounding back from the ground. It started again, but Q was continuously moving on. That's why Q took 2 seconds more. Or then the direction is opposite to each other between particle Q and acceleration due to gravity. Acceleration due to gravity acts downward, whereas Q was the Q's, look at this, the velocity of Q was upward. Here we have written the velocity of Q after the collision was upward, I mean direction was upward. So we will have to write negative half into 10, and T is no more T, as I have told. Q was continuously moving onward. That's why the 2 seconds P took to reach the ground, with this instant. In this time also q was moving onward, so q took 2 seconds more. It will be 2, okay, whole square. Or it is going to be 10t plus 20 minus 5, it is t square minus 4t plus 4. If we simplify, it is 10t plus 20 plus 20, it is plus 20. Let me write this 20 more precisely. 20 minus 5t squared plus 20t, sorry, it should be plus, so it is going to be negative symbol. It is negative symbol. Negative 20t minus 20 minus 20. Well, if we simplify, the distance traveled by q, the distance traveled by q is going to be 10t minus 20t, so minus 10t, and minus 5t square minus 5t square, and from 20t if we subtract 10t, it is 10t, 20 and 20 can dissolve each other. So this is the displacement traveled by q, okay. Then let us see the one displacement traveled by p. P traveled 10t minus 5t square, whereas q traveled this distance. And our fundamental concept from which we started our solution was that the both of the particles traveled, both of the particle collided at the same height from the ground. So let's see the what will be our equation. The distance traveled by p must be equal to distance traveled by q. Now the question is, will it be balanced? If we write this, it's not 100% correct, because look at this, p was after the first collision, p was above 20 meters. That means before first collision, let me go back to let me take you go back to this one. Look at this, the first collision happened above 20 meter from the ground, above 20 meter from the ground. So q was already above 20 meters, isn't it? But p started from the ground. For the rebounding back, p started from the ground, whereas q was already above 20 meters, because after the first collision, during the first collision, q and p both were at the height of 20 meters. Later on, P came down and went up, but Q was moving onward from that height. That means the distance traveled by total distance, that means height from the ground, because our concept is height from the ground will be same when the particles collide each other. So if we want to make it equated, then SQ20 should be added to SQ. I think you have got my point. SP started from the ground, but SQ started from 20 meters above the ground. That's why 20 should be added to the displacement of Q, so that they are balanced. Now their distance traveled by each of them will be equal. So let's solve this. SP is equal to 10t minus, SP is 10t minus, let me rewrite this, 10t minus 5t square, 5t square, and displacement traveled by q was minus 5t square, minus 5t square, minus 5t square, minus 10t, and it was above 20 meters height, so 20 should be added to q. Then if we simplify this, we are going to get, what is it going to be, 10t minus this is 10t, 10t, okay, because it was 10t, don't get confused, it was minus 10t. Well, So 10t and minus 10t, it is actually positive 20t. It is going to be positive 20t, positive 20t, and minus 5t square and minus 5t square, they can dissolve each other, and on the right side there remains only 20. If it is dissolved, there remains only 20. So 20t is equal to t. That means our t is what? T is equal to 1 second. 1 second. So what have we learned from this? After 1 second of rebounding back of p, they collided again. They collided each other again. Now we are to find, this is the time they took. I mean p took or q took to collide. Now we are not find actually the time they have taken for collision. We are to find the height. Hence our height, final answer, height is going to be, so height means the distance traveled by p as well as q. So sp was what? 10. Height is equal to sp. Let me write it. 10 into t. The value of t we have obtained. It is 1 minus 5t square. 5t square, t means 1. So hence our h or height is going to be, what will be the height? 10 minus 5 means 5 meter. So at the height of 5 meter, they collided each other again. I think all of you have understood as far as I explained the solution. So for solving question number 3, actually the concept is, the fundamental concept of viewpoint is, when two particles collide each other, they must collide at the same moment as well as at the same height from the ground. So what did we do? First of all, we should know the time, and for time, first of all, we know we should know velocity was also comparative. They have told half of the velocity when p reaches the ground. That's why we have found half of the velocity was this. Half of the velocity was 10 meter per second. After that, we found that the time taken by p to reach the ground, look, t took 2 seconds to reach the ground, but during this time q was continuously moving on. So actually q took 2 seconds more, because for p we are subtracting this 2 seconds. For p we are starting just after it rebounds back from the ground. That's why p is losing 2 seconds, but q is using, consuming these 2 seconds, because still it was in motion. After that, then we found the distance traveled by each of them. P traveled this distance and q traveled this distance. As we have now forgotten, q took 2 meters 2 seconds more, because q was continuously moving upward, whereas p reaches the ground again moved up. So as we are calculating the height after the rebounding back of p, that's why the time taken by q before the rebounding up or before reaching of p to the ground should be calculated. That's why q took 2 seconds more, t plus 2. Then finally we have obtained that they took, after 1 second of rebounding back of p, they collided each other. Then easily we can find the height. Height means the distance traveled by each of them, plus 20 for q. So height means the distance traveled by p from the ground, or distance traveled by q as well as plus 20 meter, because it was already 20 meter above the ground. So that's all about the whole solution. I think you were attentive while I was uttering each of the words. And thank you all for watching the video. Fi amanillah.